and welcome back to Statlab. Today we're going to continue our discussion of confidence intervals, but we're going to look specifically at intervals for two proportions that I had already talked about in the first video. So if you have not seen the confidence interval video, you can find it right here, and I suggest watching that first. So for two proportions, the confidence interval, we need two p-hats. So we need our p-hat 1 and our p-hat 2. So this would be our successes in our first sample divided by the sample size and our successes in our second sample divided by the sample size. Now, to calculate the confidence interval, you would have this equation here. Now, this piece right here corresponds to the margin of error. We'll just move that over there so we can see that. And this Z star, this is found at the bottom of the t-table, and it depends on the confidence level desired. We're going to use a question that we talked about last time. And so Sasha was investigating another favorite Canadian snack, ketchup chips, and she specifically wanted to know whether the proportion that like them is different in Atlantic Canada versus the rest of Canada. So when we're doing a confidence interval for two proportions, we're going to be comparing two populations. So in the previous video, she had selected 200 Canadian adults and found 122 said yes, they enjoy ketchup chips. So now she's randomly selecting 150 Atlantic Canadian adults, and she finds that 108 like ketchup chips. So the first thing, of course, we check is our assumptions and conditions. And for this, we're going to start with the independence assumption randomization condition. And we're going to say this condition is met because she randomly selected the samples from the population of all Canadian adults and the population of all Atlantic Canadian adults. Now for our success/failure condition. In our first sample, we had 122 successes and 78 failures. In this one, we have 108 successes and 42 failures. Now you may notice that for the success/failure condition, I didn't use that n times p. And that's because in this case, we don't have a known proportion. We are simply comparing two sample proportions. So I'm going to go ahead and use our direct successes and failures. So of course, this condition is met because both the successes and the failures are greater than 10. So let's now look at our sample proportions and how we would calculate them. As I mentioned before, our formula for p-hat 1 is going to be our successes over our sample size, which was 122 over 200. That gives us 0.61. For our Atlantic Canadians, we had 108 successes for a sample of 150, giving us a p-hat 2 of 0.72. So we can move that on over there. Now, if you watched the last video, you saw how I've got Z star. This time I'm just going to give it. It's 1.960 for a 95% confidence interval. Again, take a look at the other video if you're not sure where that Z star comes from. Okay, so the first thing we're going to do is calculate this. So we're going to use this formula. Now, a lot of times in first year statistics, they don't actually make you use this formula. They might give you the formula and ask you to plug the values in, but the interval is often given to you. But for this demonstration, I am going to do the full calculation. So we put in our p-hat 1 or p-hat 2, we fill in all our values, and we get down to negative 0.11 plus or minus 0.0986. So our 95% confidence interval of the difference between P1 and P2 is going to be minus 0.209 to minus 0.11. So the next thing we want to do, of course, is to interpret the confidence interval. And the wording for a two proportion is just slightly different, and you have to be careful with this. So I'm going to talk about the couple of different examples of the way it can sound. But first, let's do the one that we're working with. Since the assumptions hold, we are 95% confident that for the population of all Canadian adults, the proportion that like ketchup chips will be between 1.1% and 20.9% lower than for the population of all Atlantic Canadian adults who use ketchup chips. Now notice that I did not use the negative in my sentence. I merely said the numbers and I used the word lower. Don't use the negative, use the words to say whether it's lower or higher, and make sure that you're putting the numbers from smallest to largest in their positive form. So we can see that 0 is not in the confidence interval. Therefore, we cannot say that there is a difference. If we conducted a hypothesis test at the 5% significance level, we would conclude that there is a difference. And if you watch the video on two proportion hypothesis testing, you would know that we did indeed conclude. So it's important to recognize this relationship between a 95% confidence interval and a 5% significance level test. They must agree with each other. So let's suppose, though, that 0 had been in our 95% confidence interval. Let's look at how the interpretation would sound a little bit different. Say this was our confidence interval. So as soon as you see a negative and a positive number, you know that 0 is in your confidence interval. And if we were going to interpret this in context, it would sound something like this. Since the assumptions hold, we are 95% confident that for the population of all Canadian adults, the proportion that like ketchup chips will be between 16.9% lower and 3.1% higher than for the proportion of all Atlantic Canadian adults who like ketchup chips. So this piece here is what sounds different. Before I just said between 2% higher or lower, but if it's mixed, you have to say between this lower and this higher. Now this time we would not be able to conclude at a 5% significance that there is a difference because we found 0 in our confidence interval, which means 0 difference is one of the possible answers. And therefore, if there's 0 difference, then there's no difference. So as soon as it becomes a possible answer, we would not be able to conclude at a 5% significance. So hopefully this video helped just clarify a little bit of the difference between the 1 proportion and the 2 proportion for confidence intervals. In our next video, we are going to look at how you go about getting full marks on all your answers. Students are often very frustrated with statistics questions when they get the numbers right, they do the calculations right, and then they give you this sentence for their answer and they lose a whole bunch of points. And sometimes they don't quite understand why they're losing those points. So in the next video, we're going to look specifically at what exactly has to be in your answers to make sure that you get full points. So if you like this video, go ahead and hit like, and if you want to see more videos like this, hit subscribe, and I will see you in the next video.